Hello everyone, and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Now that we started filling up the remaining gaps in our level, it is time to start talking about the active tiles. As the DOS game modding wiki puts it, this is the fun stuff. All the things that move, such as enemies, bonuses and items, but also doors, keyholes, stuff like conveyor belts, elevators, and even some special effects. This is way too much stuff to cover in a single episode, but we'll have to start somewhere, so let's do that today. We'll focus on implementing the ACME sign, since I promised that in an earlier episode, and we'll try to do that in such a way that we can expand on that for the other active tiles in the future. What I've done first is analyze the ACME sign that falls down in the original game to see how the shake animation works, how many frames it takes up, and what the falling speed of the ACME sign is. And with that information, I think we can get started. Alright, so we got a lot of ground to cover today, so let's get going. So let's start by creating a new class that will hold our ACME sign. And our ACME sign has a X and a Y coordinate in the map. And let's be able to get X, get Y. And then in the resource loader, we should recognize the tile and create an instance of ACME. So else if the tile ID is the ACME ID. So let's go ahead to the shikari.net website. And I've already looked it up. Here we have the tile ID for the active tile. That is the loose ACME sign. That's 302A. So if our tile ID is 302A, then this is an ACME sign. So this will create a new ACME sign. We need to get our X coordinate, and we need to get that from our I address. So we need to mod it with the tiles, the level width, and then multiply that by the tile size. This gives us the world X coordinate. And then for Y, we need to divide it by the level width and multiply by the tile size, and that gives us the correct coordinates. Let's track the signs in a list, because there might be more in a level. Let's make a new array list here, and then acmes.add new ACME. And then here we'll add it to our constructor, private list ACMEs, add constructor parameter, do the refactor, import the list, and let's do get ACMEs here so that we can obtain it later to draw them. Okay. Now in order to draw them, we need to have the object tile sheet, because as you can see here, the tile index for the ACME sign is located in object1.dn1, tile number 33. And the object files are the last one that we haven't read yet, so let's go ahead and add those. Yeah, let's duplicate this one here. Read object, object 0, 1, and 2. And then let's go to GFX and add it here as well. Object here in init, object equals loader read object. All right, and then when we draw the level, let's assign this get level business here, because we're doing it already 3 times and we're going to add a 4th. So let's assign the level. And then when we're done with the level geometry, we can go over each ACME sign, and we can say graphics.drawImage object.get. Okay, so we need to know which tile ID it is. So object 1, tile ID 33. Each object file contains 50 tiles. So I'm guessing it's tile 83 for us. So Let's go ahead here, do 83. And now here we have the acme.getX, but we need to offset that with the camera to translate it to the correct screen coordinates. And the same with getY. So let's subtract the camera Y here and the null observer. All right, let's run it and see what we have. Okay, we got half an ACME sign, so I guess the ACME sign is made of 2 tiles. So let's go ahead and add that real quick here. Let's rerun. All right, but we already have a little problem because the ACME sign gets drawn regardless if we're inside of the viewport of the game. So here now, all of a sudden, it appears inside of our health box. So we need to check of these individual tiles if they are visible or not. And with visible, I mean within like this game area here. So let's go ahead and create a method that is able to draw tiles only if they're visible. So yeah, let's go here and let's make a private void draw tile that takes in the image of the tile it wants to draw. Guess we need the graphics, what we're drawing to, and we need the world X and Y coordinate. And then here we can say like if is it visible, then we'll do graphics dot draw image X minus camera X, Y minus camera Y. Okay. And I'm guessing if we're calculating the screen coordinates, we just need to check. So let's assign screen X and then screen Y. So if screen X larger, greater than 0, and screen X is less than, how wide are we going here? So 15 columns, so 15 times 16 is 240. So screen X needs to be less than 240. And then the same goes for screen Y. Needs to be greater or equal to 0. And then lastly, screen Y needs to be 12 times 16 is 192 pixels at most. 192. All right, so if we are on the screen, let's draw it. So we can go back into here and we can say draw tile. And then this object here, ACME X, ACME Y. Oh, get Y. And we need the graphics object as well. And then for 84, it's ACME X plus the tile size because we need to draw one to the right. Okay, let's see if we can still see some invisible stuff. Oh, I just saw it pop up there at the bottom. Oh, and we are one tile too far, it seems. Okay. Yeah. So let's just subtract 16 from everything. So this will be 224, and then this will be 192 minus 16. I'm horrible at this. Is 176. And let's try again. Okay. Yeah, now it's better. So now we do not see the ACME sign when it's out of bounds. So I think that's great. All right, so let's work on the behavior of the ACME sign, because if we are to walk underneath it, it should fall down. So let's go back to the ACME sign here. And let's give it an update method. Public void update game state state. All right, so we need to, I guess, keep track if we are private Boolean Guess we need to keep track if we are falling. So by default, we're not falling. And then if our y is less than, we need to get an instance of Duke. Duke state get Duke. So if our y is less than Duke's y, then we're above Duke. So that's good. And if our x is less than Duke's x, then that means Duke is to the right of us. And if our x plus 32, because our width is going to be 32 tiles, so I'm guessing 31 here. If that is, let's see, our x needs to be less than Duke's, but our x plus 32 needs to be greater than Duke's x, then I think we should fall. Falling is true. And then we can say that if we are falling, let's just increment our y, I don't know, by 4 each frame, because we need to actually call this update method. So let's go to our game state. And then here we have duke.update this. So we also need to update the level. So let's update the level with this. Then let's go here. And let's do state here. And then here we can say get ACMEs for each update. ACME update. Okay, why is this not doing what I want it to do? Oh, we need to pass in the states, right? Okay, cool. Yeah, ACME update state. Okay, so now we should update it each frame as part of the level update. So let's see what happens now. All right, it falls down and it leaves behind a gap here. So let's quickly fill that up in our read level method. We'll do the same what we did earlier for the start location. We'll assign the left tile as a gap filler. Okay. So as long as we are above the ACME sign, it doesn't fall. And then if we go underneath it, there it goes. So that works. So for now, if we're falling, it needs to shake first. And it needs to crash in the floor once it's done. So what we'll do is we need to check if our if our new position is colliding with the level. So can we collide with the level? For our x, y, and our width is 31. Our height is 15, I'm guessing. If we do, then I don't know, let's call the crash function, private void crash. Falling is false. This should stop the block from falling once it reached the floor. Okay, so the falling flag gets overwritten as long as we stand beneath it. So I think we need to do a check if we're falling first. Then we increment y with our falling speed. And then else we'll check if we need to fall. And then as part of our falling code, we can do the crash check. All right, so now I expect the first frame, it will go down 4 pixels, but then it will conclude that it's inside of the ceiling that it's inside, so it will stop falling. Okay, so let's see, we'll need to keep a new Boolean, private Boolean active, I'm guessing. We'll set active to true. And then here we can say active is false. And then is active And then in the level, we'll just for now do also an active check. If we're active and falling, else, so I'm guessing just only update if we're active. Only update if we're not active, just chill on the floor. Okay. Yeah, so now it just goes down 4 pixels and then it concludes that it's colliding with the ceiling. So I think what we'll do is, because we also need to keep track of shaking. So let's just keep a counter, private int counter. And then I guess we can just keep track. Okay, so if we are active, then check if we are already falling. Then increment y with 4. And then here we'll just check if our counter is greater than, I don't know, 2. Let's make a fall speed, private static final int fall speed. The block is falling pretty fast. Let's go ahead with 14. And then we only want to do some collision detection if we have been falling for a few frames. So let's say for 2 frames. I think that should do it. Yeah. So that looked a lot better. So now all we have to do is implement the shake that happens before before the block falls. The block first shakes for a couple of frames. So let's go ahead and do that. So let's see. Let's rename this falling thing to dropped, or something, or dropping, because it is dropping on top of Duke. Well, it's falling as well, I suppose. All right, so if we're active and if we are dropping, then depending on the counter, so if the counter is less than 14, for example, shaking, so we'll figure that out in just a sec, else we'll fall down and possibly crash. Here we need to make sure our counter is great enough so that we've cleared the ceiling, so that we don't collide with the ceiling. And then here with the shake thing, we can say x is x plus, and then if the counter is even, then we'll do 0, and otherwise we'll add 1. But we need to do -1. So this should shake the block for a couple of frames. All right, so it totally disappeared on me. So let's disregard the shaking for now. So now it stays there and then falls. All right, so all we got to do is figure out how to do the shake thing. So our x needs to be either x should be x or x should be x plus 1. But if x was incremented by 1 last time, we need to actually decrease it x minus 1, right? Yeah. So on the very first frame, on the counter frame, we should just do nothing. And then we need to start plussing and minusing. So we'll just say if counter is 0, do nothing. Otherwise, we increment x plus, and then if counter is even, if the counter is even, we need to do -1, and otherwise we need to do 1. All right, so first time do nothing, x should just not change, and then the second frame, the counter is going to be 1, so then it's going to be odd, so then it will add 1 to the offset, and then it will subtract 1 again, and then it will fall down. So let's see if it shakes now. It shakes, but it uses the X. Of course, I should have used Y. All right. All right, there we go. We have a falling ACME block. It doesn't hurt Duke just yet, and it should also explode when it crashes into the ground. But for now, I'm pretty happy with how this turned out. Let's take a few minutes at the very end to make some reusable code out of this, because right now what we've done is we've added like a list of ACMEs to the level and then doing really super specific stuff here into the graphics class to draw the specific tile for the ACME sign. So that's not very nice. So let's go ahead and create an active base class that is abstract, that has a X and a Y. And let's create a constructor for both of them. And let's make that protected. And let's make a getter for each. Get X and Y. I'd like to have it the other way around. All right, and then let's have ACME extend this active thing. And then we'll do super X and Y. And then this active is going to also have the public void update with the game state. This one will also have the active boolean, protective boolean. And I'm guessing I'll just call it dead, so it's false. No, let's just keep it at active. So it starts at active is true, is active. And then here we have our update method. All right, so this ACME sign overrides this update. We do not need these getters here anymore. We can get rid of these because they're all in the superclass. So all we need to know is that if we're dropping and if we are countering. And then that's pretty cool. Let's move the fall speed flag constant all the way up. Okay, and then let's say that in the level, instead of a list of ACMEs, we have a list of actives. Yeah, get actives, return actives. So now we can reuse these actives, get actives dot filter is active for each active update state. So this will only update actives that are still active. Yeah, so we can remove that from the ACME sign, that we do not need this explicit active check here anymore because the level does that for us. Yeah, let's do it like this. I might clean this up later, but for now it works. So like I said in a previous episode, make it work, make it right, and then make it fast. Okay, so now in the GFX, we are looping over ACME. So let's do the get actives, active get X, active get Y, active X, tile size, active get Y. We also need to do this in a different spot now as well. And in the resource loader where we load up the level, we'll say here that we'll have a list of actives add ACME, actives. Okay, so now if we rerun, it should still work. Or maybe not, it crashes. No pointer. Main, loop, actives, stream, filter, Okay, yeah, this actives is, yeah, I messed this up here. There we go. Did not get assigned properly. All right, so we're back here and it still works. So that is cool. All right, so next episode, I think we'll add in a new active element. I think we'll do the camera that follows Duke around. And then we'll also fix the drawing of the active elements. Because right now the graphics class is responsible for it, but I think we should move this responsibility to the active class itself. So I would like these draw tiles here to go into this ACME class here. But we'll do that next episode. For now, I want to thank you very much for joining me. If you have any questions or remarks, feel free to put them in the comments below. If you like the series so far, consider dropping a like and a subscribe, and I'll see you guys in the next one. See you later.